Good morning, everyone. I welcome you all for the first session of projection of solids. I, Mr. Prasad Kallolimat, Department of Mechanical Engineering, SG Balekundra Institute of Technology, Belagavi. Projection of solid. A solid may be defined as three-dimensional object having length, breadth, and thickness, and bounded by surfaces which may be either plane or curved or combination of the two. The different types of solids are prisms, pyramids, and polyhedron, and solids of revolution. To begin with prism is a solid formed by joining two regular polygons placed parallel to each other and are joined by rectangular surfaces. Some of the prism are as shown. So these are the some of the prisms shown. First one is triangular prism, square prism, rectangular prism, pentagonal prism, and a hexagonal prism. As said, a prism is a solid formed by joining two equal regular polygons. For us, say suppose if I consider a square prism, this is a polygon, regular polygon of a square at the bottom, and this is a regular polygon at the top. These two are joined by a rectangular face. So the rectangular face for me is this part which has been joined from the top base to the bottom base. These regular polygons which are there at the bottom, we call it as a bottom base, which is at the top, we call it as a top base. And these bottom base and the top base are joined by a rectangular faces. And we should know some things to know about the prism is the line which runs from the top base to the bottom base, we call it as a longer edge, which is joining the corner of the top base to the corner of the bottom base, we call it as a longer edge. Similarly, if a line which is joined by only the corners of the bottom base, such as this edge, we call it as a base edge. We call this edge as a base edge because it is joined by two corners of the same base. So that edge we call it as a bottom base edge, and if it is joined by the top, it is called as a top base edge. And I have an axis. I should know an axis. Axis is nothing but an imaginary line which runs between the midpoint of the center of the top base to the center of the bottom base. It is an imaginary line which runs from the midpoint of the top base to the midpoint of the bottom base. That we call it as a axis. So let me repeat. We have studied what are the different types of solids. Then what is a prism? In prism, what are the different types of prisms? That is triangular prism, square prism, rectangular prism, pentagonal prism, and a hexagonal prism. A prism is nothing but it is solid formed by joining two equal regular polygons. So the bottom polygon we call it as a bottom base, a top polygon we call it as a top base. It is joined by a rectangular face and a edge which runs from the top base to the bottom base. We call it as a longer edge, and a edge which is joined by only the corners of the bottom base or a top base. We call it as a base edge. And then we know the axis, it is the imaginary line which runs from the midpoint of the top base to the midpoint of the bottom base. Next part of the solid is pyramid. Pyramid is a solid formed by joining a triangular faces from one polygon to that of the apex or vertex. Apex or the vertex is nothing but this part. It is joined by a triangular face. Say for example, this is my triangular face which runs from the bottom. So I have at the bottom, I have a regular polygon. Say this is a rectangle. This rectangle is joined at the apex through the rectangular faces. So we call such type of polygons, such type of solids as a pyramid. Along with that, we should know what are the slant edges. Slant edge is nothing but a edge which is joined from the apex to the base corner. Slant edge is the edge which joins from the apex to the base corner. That we call it as a slant edge. Then we call this polygon which is there at the bottom, we call it as a base, and the edge which is been joined from one corner to the other corner, we call it as a base edge, and it is denoted by a line. Then we should know axis. Axis is nothing but again an imaginary line which runs from the apex to the midpoint of a regular polygon. So this is about a pyramid. Then we have the third type, polyhedrons. Polyhedron, the two main polyhedrons are tetrahedron and a hexahedron. Tetrahedron is nothing but it is formed by joining four equilateral triangular faces. Four equilateral triangular faces means what? I have one slant edge from the apex to the corner. That means it is nothing but a pyramid where my bottom regular polygon, what we have at the bottom, is a equilateral triangle and it is joined by a triangular faces that is also a equilateral triangle. So base is one equilateral face, triangular face. Then I have three slant faces which runs from the two corners and one apex, two corners and one apex, such as we have four equilateral triangular faces. Such type of a polyhedron we call it as a tetrahedron. Then hexahedron, it is nothing but a cube. It is formed by six square faces. Four are four are my uh, walls which are surrounded. One is at the top and the other one is at the bottom. So all six are nothing but a square faces. Such type of polyhedron we call it as a hexahedron. Then we have a cylinder. Cylinder is nothing but a vertical line revolved around its axis. Then we have a cone. It is an inclined line revolved around the axis. So this is the vertical line revolved around the axis, and this is the slant line which is revolved around the axis. We call such type of solids as cylinder and cone respectively. And for our syllabus point of view, we shall discuss that the solid is resting on HP on one of its base only. We have for our syllabus only with respect to the solid resting on HP on one of its base only. So we will begin with the problems. Before I start with the problem, let us go with the question which will be in on your screen shortly. Let's not waste our time. Start with the problems immediately. So this is the first problem. on square prism. So let us take some time to read the question and understand the question. I'll give 2 minutes to read it. Kindly read the question. Okay, the question goes like this. A square prism, 35 sides of base and 65 axis length, rests on HP on one of its edges of the base, which is inclined to VP at 30 degree. Full stop. Is inclined to HP at 45 degree. So to understand, I have drawn a square prism. For me, this is a square prism where I'm naming this square as a bottom base, and I have given the corners as A1, B1, C1 and D1. These are the corners which is a point, and these corners I have named it with A1, B1, C1 and D1. The corners of the base, if two corners are joined by a line, we call it as a edge, base edge, and then this is a top base of a same square. I'm naming these corners as A, B, C and D. Top base we are naming it from A, B, C and D. Bottom base we are naming as A1, B1, C1 and D1. Then we have longer edges running from the top corner to the bottom corner. So we call those edges as a longer edge, which is A1. Then I have C1. Then I have B1. Then D1. So we have the four longer edges, four base edges of the bottom and four base edges of the top. Then we have an imaginary line which runs from the center midpoint of the top base to the midpoint of the bottom base. That length we call it as a axis length. Once I understand what a prism is, I should go back to a question, read the question. I have a square prism of 35 sides of base. So this is my base. This is my base. This base side is of 35 This base side is of 35 Then 65 axis length. So this length is of 65 This length is 65 Rests on HP on one of its edges of the base. So it rests on HP on one of the edges of the base. So for me, I take this bottom base as a base, which is resting on one of these edges. Let it be A1, B1, B1, C1, C1, D1 or D1 to A1. It is resting on one of these edges. So my edge has to be on my right hand side when I start drawing. So I have to draw a square of 35 So what I do now, the first thing as soon as I get a problem is I have to answer two questions. That is where it is resting and how it is resting. Always where it is resting in solids, it will always be resting on HP according to our syllabus. It will not vary. How it is resting itself, I want to understand from the problem. So from the problem, I have understood it is resting on one of the base edge. So this base edge has to be on my right hand side. So what I do now is I start drawing my XY line. So first thing what I do is I draw a XY line. Then I write down XY. Then I write down, this is my vertical plane. This is my horizontal plane. I draw a square of 35 mm where a edge has to be on my right hand side. So I have a edge on my right hand side. I'm going to name it and dimension it. So this length of this edge is nothing but it is 35 mm. The length of this is nothing but 35 mm. Then I'm going to project it on top. To understand the midpoint of this square, I should draw a diagonal. So this is my midpoint of this. I'm going to project it on top. I'm going to name this first. Only the edges. As of now, I'll name it A, B, C, and D. And then come back and finish the namings. My axis length is 65 mm. So I draw an axis of 65 mm. And the axis line always it should be with a chain line. Chain line is one large and one small, one large and one small. So this is my chain line. Axis line has to be always with the chain line. So I know this is 65. So I just finished down this prism now by projecting all the lines on top. Then draw the top base. So I'm looking this whole thing from here, this end. That means B and C are visible. So here I'll be having B, I'll be having B outside the bracket, within the bracket A. So it is B dash and A dash. And this is C dash and D dash. So that is about my top base in 3D. So A, B, C, and D. I have written A, B, C, and D. At the bottom, I have again A1, B1, C1, and D1. So whatever I have here, I'll write this with the suffix 1. So it is B1 dash into the bracket A1 dash, and this is C1 dash into the bracket D1 dash. This point is O dash, and this point is O1 dash. Now I'm going to rename the top base. I have only written A, B, C, and D. I don't know where A1, and B1, C1, and D1 are and how they are. when I see the longer edge, A1 is my longer edge, and A is visible. I'm seeing this from the top. I'm seeing it from the top. A is visible, A1 is not visible because A1 is merged with A. So A is visible, A1 is not visible, so it will be in a bracket. Then I have one more longer edge, that is B1. Again, B is visible and B1 is not visible because B1 is merging with B. So this is in the bracket B1. Then I have one more longer edge, C1. C is visible, C1 is not visible, C1 is merging with C, so C1 is within the bracket. Similarly, on the similar note, D1, D is visible, D1 is not visible, so I'm writing D1 within the bracket. Then for the axis, O is visible, O1 is not visible. So O1, I'm writing it within the bracket. Now, when I go further, draw the projection of the prism when axis is inclined to HP at 45 degree. I have this axis which has been inclined to HP at 45 degree. Now when I draw a axis, I don't know how to draw this because this whole part I have to whole solid I have to tilt in such a way that I get the axis. I have to have an axis of inclination of 45 degrees. So what we do is, instead of going with the axis, we convert this axis inclination to the base inclination. So what we do is, I have a solid which is like this. I have a solid which is like this. Then I have an axis. This axis is inclined to HP on this. It is inclined to HP. This is my XY line. This axis is inclined to HP to what angle? To 45 degrees. So from where I should draw my axis? So this is 45 degree. So what we do is regularly we convert this axis inclination to the base inclination. So if I develop this axis at the bottom, this part is nothing but it is 90 degrees. This part is nothing but it is 45 degrees because the axis inclination is 45. So this is 45. This part is 90. Out of a triangle, I have a triangle here. This is 90. This is 45. The whole angle is 180 degrees. 180 minus 90 minus 45. So this inclination for us will be nothing but 45 degrees. So we are converting the axis inclination. Say for example, I'll draw it a bigger. This is my solid, what we have. It is resting on the XY line on HP. This axis is making an angle of 45 degree. So this angle is 45 degree. So I want to convert this axis inclination to base inclination, for which I'm drawing extending this line. So this point will be 90 degree and this angle will be 45 degree. So for me, if I consider this as a triangle, that is A, B, C, one A, B, and C, I get inner side should be nothing but the total angle of should be 180 degree minus 90 minus 45. So for this, it will be nothing but 45 degrees. So this angle for me, it is nothing but 45 degree. That is the base inclination. So now what I do without wasting my time, I know the base inclination, it is 45 degree. So I just draw 45 degree. I just draw 45 degree. Then I measure these length. It is from this end, it is 35 mm from here. So out of which it is a midpoint. It is 17.5. So the total length is 35 mm. I cut this down and axis length is 17.5, which is at this point. Then I draw 90-degree lines here. Then I know the length of this is 65 mm. I just join it. Then I'm going to name it. So this is C1 dash D1 dash. This is O1 dash, and this point is B1 dash and A1 dash. This point is B dash A dash. It is O dash C dash D dash. Then I project all these to the bottom. Then I project this sideways. I have A1 coming from here and A1 from here. So this point is nothing but for me A1. Then B1 from here, B1 from here. So this is B1. C1 from here, C1 from here. So this is C1. D1 from here and D1 from here. So this point is D1. On the similar note, I have A from here and A from here. So this point is A. B from here and B from here. So this point is B. And C from here, C from here. This point is C. And this point from D from here and D from here, it is point D. I've got all the points A1, B1, C1 and D1. So what I do is I join all the lines. A1, B1, C1 and D1. A, B, C and D. I join it. Then I have to make sure I'm joining the longer edges. Longer edges are nothing but AA1, BB1, CC1 and DD1. So A1, A is from here, A1. So I've not joined it, so I'll join it, A1. Then I have BB1, I have not joined, BB1 I have not joined, so I'll join it from the top base to the bottom base. So it is BB1, then I have CC1 and DD1. So it is complete. I have to make sure always that I join all the longer edges which run here from the top base to the bottom base. Then I have to draw the axis which runs from O to O1. So for me, the axis is a axis line, one large and one small, which meets at this point. So O is from here, O is from here. So this point is O, this point is O1. So with that, my problem is over. This problem, this second phase of the problem, but we should know the hidden lines. We will come back to the hidden lines after few minutes. The third part of the problem is it rests on HP on one of its edges of the base, which is inclined to VP at 30 degree. The same edge on which it is resting, that edge is inclined to VP at 30 degrees. So the same edge, the edge on which it is resting is nothing but it is C1 and D1. The edge on which it is resting is this edge, which is nothing but C1 and D1. So this is the point which is resting C1 and D1. So C1 and D1 is the point which is resting here. Now for me to know the hidden lines, the line running from this point will be a hidden line. The line running from here, I'm going to see this whole solid from the top, and a line running from this point will be a hidden line. So A, from this line, how many lines are running for me is from C1 to B1 and D1 to A1 and C1 to D1 as well as D to D1 to D and C1 to C. Now I come back C1 to B1, it is the outside line, so it will not be hidden. D1 to A1, again it is the outside line of a solid, it will not be hidden. Then D1 to D, it is already merging with the top base as well as AA1. AA1 is a line which is running from here to here and it is already visible, it is a front line. So as well as CC1, again it is been merging with BB1 as well as C to B, that is the top base. So again the hidden line will be within that. Only one hidden line for me will be nothing but running from C1 to D1. So for which what I do is I draw a dotted line. For C to D1, I draw a dotted line. Since I'm drawing it with a pen, I've just accentuated it to side. So C1 to D1 will be my dotted line. Next is my base edge has to be 30 degrees. The base which is resting, it has to be 30 degrees. Now what I do, since I'm having a lesser space here, I'll just continue this part with somewhere here. So I draw a line. I'll just, or else I'll just continue this on the other page. This is my XY line. This part, this is the base edge. This base edge is making an angle of 30 degrees. So what I do, I measure angle of 30 degree here. I measure angle of 30 degree and draw the line. Okay. Now I have to place this C1D1 on this 30 degree line. So for which what I'll do is I'll place this C1D1, which is nothing but same 35 mm. So what I do, I'll place it anywhere I want here on this 30 degree line. The length of that is nothing but 35. So I'll place it here. It is 35. Then what I do, I draw 290-degree line. From here, I draw 290-degree line. Okay. So this is nothing but for me. I'm going to place this whole thing. I'm just going to place this whole thing here. Before I do this, we will continue this part in the next session because we are short of time. So before I end up today's session, we have taken up two phases of the problems. That is the first phase, that is the top view and the front view. Next phase is the third one, where we converted the axis inclination to the base inclination, for which again I need to draw this as an axis line. Then extend it and measure it as 45 degrees. Then we have projected from the top to the bottom, then the sideways. Then we have named the projections of the corners which are running from the A to A1 to A1 here, B1 to B1 here. That is, we have identified the bottom base and this is the top base. Then we have the axis. In the next part of the problem is this edge, that is C1D1, is making an inclination of 30 degrees with respect to VP. So next part of the problem we will take it in the next session of the class.